All right, so we're going to get started. The first thing I want to do is to kind of go over, if anyone is interested, we can kind of go over the, I thought I posted in here. Okay, the due date is set to tomorrow, so I'm resetting the due date to the 28th. So you have 2 more days to work on it, but this is, this assignment really should not be too difficult. Once you know how to structure the program, it really is a lot of coding. No, that's not true.
For me, it's so hard.
It's so hard. Okay, well, keep working on it.
I'm making progress.
You're making progress. Very good. Now I cannot remember where I stashed socket 1. Did I send you a message? Send you guys a message about socket 1?
You posted a link in the forum.
Okay. Oh, the forum. That's it. Not the news forum, but the actual usual forum.
Yeah.
There we go. General stuff. There we go. Socket 1 solution. So now we have it. Okay. So what I will do, first is to take a look at the source code. I'll just kind of go over it really, really quick because socket 1 is a program that we have pretty much done already, and I'll just go over that. Just a few major points. All right, so that's done, and we'll go ahead and take a look at that. And this is socket1.c. It's my implementation. Doesn't mean that your implementation has to be the same. There are many, many ways to get the same program done. So it's entirely up to you to decide how you want to structure your program and as well as your programming style. I did not comment this program because I think people who want to read this program to get some idea of how to get started with Socket 2 really should go over this program and do the documentation. It's a good exercise to actually try to understand this program and also learn in the process how do you get started with the next one. So we'll go ahead and start with main itself, and let me turn on the line number so this way we can refer to the line numbers when we go through the discussion. Main has 2 parameters. Normally we don't use these, and that's why in many programs we just use a void for the parameter list because we do not make use of argument count in the argument itself. But in this case we do. This is just my trick, with all the flags that I need. These are flags that I need to pre-declare just so that when I go through the loop to parse the options, to parse the parameters, I can rely on these flags. I can use these flags to remember, how the program is supposed to run. One is basically just a Boolean. I'm abusing, 32 bits just because I want to use 1 bit out of the 32 to remember whether it is supposed to run in server mode or not. It is initialized to 0, which means by default I do not want to run in server mode. I only want to run in server mode if I confirm that -- server is a part of the options. The second one is a pointer. It's basically a string. It is the name of the socket. So that's it's defaulted to 0, which means it's a null pointer to begin with. The first argument is not useful, so I just kind of skip it. If I skip an argument, I'm also going to decrement argument count. So I'm using argument count to keep track of how many more things I have to process. And then the loop to process the arguments starts with this. As long as there are no errors and I still have something else to process, keep this loop going. And then it's just a matter of checking all the things, checking whether it is -- server. If it is, then I turn on server mode, and I will check whether it is -- socket. If so, I'm going to check something else because I want to make sure that the actual path itself is specified after -- socket. So that's why there's an additional check here to make sure that even if I delete or if I decrement the counter, I still have at least 1 left as the socket name. Then I remember the socket name. If I do not, in other words, if argc becomes 0 at that point, then I will go ahead and print this error message and say socket should be followed by a socket name, and then print an error message like that. Okay, any questions at this point? Now, if I receive anything, if anything on the command line that is not dash dash server nor socket dash dash socket, then we'll get to this else case. And in the else case here, I just say that I do not recognize this particular option, and I'm going to stop the program right now. I'm not going to do anything. Because sometimes people have typos. So instead of silently ignoring the typos, you should report and say that I don't know how to process this. If someone types dash dash server and misspells server, like missing an E or something, in the program, and you silently fail the program or silently ignore that option, the program will run in client mode. But the person who is running the program will think that it's actually running in server mode, and that can cause a lot of confusion. If you just say that, oh, I think I don't understand this, then the person will just look at this and go like, oh, okay, so I forgot to type the E, or I have a typo mistake in the option. And then the rest of it, from main's perspective, I forgot to put a return 0 at the end, but that's not that important in this program. If I did not encounter errors, then I will go ahead and see whether I'm in server mode. If it is in server mode, I go to the subroutine called run as server. And if I'm running in client mode, I will go to the subroutine called run as client. Each one still needs to know the socket name, and that's why I'm passing socket name to each subroutine. There are no global variables in this particular program. And there should be no need to use global variables in this case. Are we doing okay so far? Yep.
What happens if it's called with no arguments?
If it is called with no arguments, then the error will happen but later on, because no path is specified. So when I try to use socket name, then it will generate an error at that time. Yep.
Like I don't remember for sure, but we didn't talk about how we should handle unknown option. Do you want us to start doing error checking like that? If it's not in the.
If it is not in the specification, I will not test for that. In other words, if I did not say, and the assignment did not say that you have to handle unknown options, so I'm not going to test how your program is going to react to unknown options. But as a general programming practice, you should try to identify problems as much as you can, just so that problems do not go forward unnoticed and silently.
Yeah, I wasn't sure if we should. I mean, there's been times when I thought, well, it'd be nice to check for that, but I'm not going to put it in there because I don't want the grading script to.
Well, once my solution is published, you can use a part or the entire program as your socket 2 or socket 3 homework assignment. Okay. So so this is all yours to analyze and copy, or if you like certain parts of it and not other parts, just copy the parts that you like. All right, so we'll go to run as a server next. Run as a server is the entry point for the server mode operation, and it's only complicated because we have to check for errors and stuff like that. The first call is to the socket call, so I'm just creating an endpoint for the socket, and then I capture the line of the error. If there's any error happening, it will capture it here. And then I will check whether socket file descriptor is non-zero. Now I know that file descriptor 0 is actually standard in, and it's not supposed to be 0, but the documentation only says that it is non-negative. So that's why I have to check against just non-negative, and I still have to allow quote-unquote 0 to be a valid socket file descriptor. Okay, because there may be occasions where the socket can be file descriptor 0. You can choose to close standard in and then do the whole thing. So if the kernel decides that, oh, since you have closed standard in already, that file descriptor is now available, is quote unquote vacant, the kernel can decide and give you file descriptor 0 when you run socket. Nothing says that it cannot. So that's why you always write your program according to the specifications of the manual, but not, well, I don't think this can happen. Well, just because we do not know whether it can happen or not doesn't mean that it will actually happen or not. And then we have a structure. This is silent. I think live support is just cut off to this room. I think that they're diverting all energy to shield or something. Wait for the lights to to flicker and then turn red.
Red light.
Yeah, that's awesome. This is weird.
Yeah.
We're so used to the background hum, in all of these classrooms. So when there you go, life support is back.
Surprised at how loud that clock is.
Yeah. The recorder doesn't really get the clock itself. It does get the background hum and also the door. Particularly the door. All right. So once we have the socket open correctly, which means the socket file descriptor, this is the endpoint file descriptor, is greater than or equal to 0, then we'll go ahead and set up for the address. And once we set up for the address, we'll go ahead and call bind. Okay. So we'll use bind to associate the endpoint with a particular name, and that's the one passed in by socket name. So that means if I did not read in a proper path, which means this is going to be a null string, then this particular call will fail because it cannot open an empty file name. When it does fail, then the error line is going to be captured here, and it's going to return a non-zero value. If it returns a non-zero value, we'll go all the way down to this line here, which goes to one of my little subroutines that makes use of __ file as a parameter, which reports the name of the source file, and also error line, which is set on the same line where the bind happens. Are we doing okay so far with this part? Kind of? Okay. If everything goes okay, if I did bind correctly, then we'll proceed to this part. Then I would ask the kernel to say that I want to start listening with this particular socket endpoint. If that fails, it will go here, and I'm doing exactly the same trick. I remember the line number, and then I report the correct line number where the listen call is happening. Because otherwise, it will only report this particular line. When you read the program, you can still kind of figure out how it can possibly get there, but it's better if it just reports the correct line number to begin with. And if everything is good, I have bind and also listen working correctly, then I will go to a subroutine that actually performs the task. In other words, everything else in this subroutine is just for setting up my socket on the server end, and the actual operation is specified by this particular subroutine. When this subroutine returns, we are all done. Unlink is going to delete the named socket. So next time when I run this program again, I don't have to manually delete the socket, the named socket. Do we have any questions at this point about this program? Yep.
Well, this is actually a question about something we're going to have to do to modify this program to do select 2 or socket 2. If we get a read condition that says that EOF has been reached, then on the server, do we actually have to close that file descriptor?
Yes.
Okay.
Yes, you will have to close that descriptor because that connection is basically gone. Close would definitely not hurt anything. Even if you don't close it, once you notice it has encountered an file, you're not supposed to wait on it anymore. So you might as well close it and then just mark that client as not working anymore, and then just skip it for all the future operations. All right, so good question. And now we are down to server task. Now you can see that this program, I could have put all of this code into the main program, except the indentation in the main program would be like quite a bit to the right hand side, because there's a lot of nesting of conditional statements. Now this part is completely stylistic. Some people just use return inside conditional statements. In other words, when they check something, and let's say the bind call failed. Okay, if the bind call failed in this case, some people just put a return in the conditional statement itself, so that all future statements will only run if the bind call was successful. Okay, I personally do not like return anywhere other than the bottom at the end of a subroutine, and other people feel comfortable with that approach, and that's entirely up to you to decide how you want to write your program. I have just been bitten by enough of those problems with returns kind of sprinkled in throughout a subroutine, and I just choose not to do it, so that the only way to get out of a subroutine is to finish the entire thing. It's very easy, to me, it is very easy to figure out, how do I go, where do I go from here? What is the else of this end curly brace? In VI, you just say close square bracket, and then you close curly bracket, and it gets to the end of that particular scope. So to me, I can actually locate, okay, what if it is not successful? I can actually figure out, what happens when it is not successful pretty quickly, just using the editor tool. But if I sprinkle returns, everywhere, it becomes harder for me to figure out how the returns are related to the error conditions. But that's just me. You guys have your own way of doing things. Everybody is different. And I know Mr. Fox does not have any problem with putting returns in conditional statements in a subroutine. I mean, that's definitely, individual.
I thought he did. I thought he did.
When he does recursion, I think he uses return inside the inside conditional statements.
Okay.
But recursion can be a very special case too. All right, so here's server task. Server task is the one thing that is specific to socket 1. In other words, socket 2 will have something that is different. Okay, not entirely different, but different. In this case, server task is going to this is a loop to wait for all 3 clients to make a connection first. In other words, I'm going, what the condition is saying, as long as there's no error condition, and as long as I have, I do not have all the clients connected yet, do the following. The first thing it does is to accept the connection from a client, and then it will stash it into clients FDS, which is an array, and then it will check, whether it is reading in, whether the accept call was successful or not. If it is not successful, I will do a error report and be done with it. If it is successful, I'm going to echo back or send back a string for the client to do something about. The client has to display connection number blah. And then at the end of the loop, I increment I so that I only have to go through this 3 times. When this is all done, then I should have I should have 3 active connections from 3 clients. Are we doing okay so far with the loop, the first loop?
Just a quick question on your format string there. Why did you use U instead of D at connection pound?
Because it is unsigned. Well, I didn't use it consistently, but I really should be an unsigned.
Okay, thanks.
Yeah. So if I should have used unsigned int I instead of int I here. So it's an inconsistency. If I turn on wall, I think GCC can actually figure out that there's an inconsistency here. It will either do the automatic casting or it will report as an inconsistency.
Wall will complain like crazy with that.
Yeah?
Yeah, but it would also complain about your array. It doesn't like using the constant.
Oh, you mean this part?
Yeah.
But this is not const, this is actually a pound defined.
Okay.
So it won't complain about the pound defined here. Because the pound defined is handled by the C preprocessor, so by the time the C compiler gets it, it's just a constant 3. All right, so here's the second loop. The second loop does what the rest of the program needs to do. In socket 1, it's really easy. All we have to do is to send a string to each client and say the circle is now complete, and then the server's job is all done. I don't even bother to close the connections, from the server side, and just the server side ends at this point.
The assignment didn't say to close those?
Did it?
I could be
I
wrong.
thought it did. But it's just, you just close them as you go through, right?
Yeah.
Yep. You can just close at
Close
right
one.
after the dprintf. You can close it. Yep. And then the run as client is a whole lot easier. Run as client is really just opening the socket, and then do the echoing. I made a little subroutine to do the echoing, because it's just easy to deal with. Yep.
Could you just go back up real quick to the where you're printing out the circle is complete?
Sure. Right there.
All right, okay, thanks.
Yep.
Why are you giving the line error there?
I do not remember. I suppose dprintf can fail too, so you can check whether dprintf actually failed or not. But
Are you using that anymore?
I cannot remember. I think it was just a copy and paste thing from the line here. I cannot remember. It was kind of late.
You have it, if you need it, you have it.
Yeah.
Did you run your grading script on this and get 100%?
It will probably do it. I actually ran it manually. I tested this whole thing manually, and it worked the way it's supposed to.
Use the grading script.
All right, so run as client is a whole lot easier because run as client only has to do the echoing, and knowing that I need to do some major echoing later on, I just decided to write a subroutine to do it, so that this way I can just call the subroutine when everything is good. After the client opens up the socket, has the connection, then all it has to do is to read from the socket file descriptor and echo it onto file descriptor 1 with the standard out. Yep.
I remember you telling me that when you called connect, you can just pass null for like the last 2 arguments, but I noticed you don't do that there. Was that just a copy and paste as well?
You mean this part here?
Yeah. I remember you telling me that the last 2 arguments of connect can be null because we're using networking and not internet protocols.
No, accept. That's only with accept.
I'm sorry, you're right.
And with
Thank
connect, you do need the address
Of
because
course.
it needs to know where it's connecting to.
I got confused.
Yeah, accept reports back where it's connecting from.
Right.
And in the case of a named socket, it is not useful because
Okay.
it's just the name of the named socket
Accept,
itself.
not connect. Okay,
Right.
thanks.
All right. So are there any questions about this program? I think for people who did not complete socket 1, the value of this program is basically all the way up to run as server. Okay, run as server for the most part can still be reused completely for the new homework assignment because once you have all 3 connections, then you go to server task, which has to be modified heavily in order to accommodate what we want to do in socket 2. But for the most part, from main to run as server, everything can still be the same. But server task is the one that needs to be heavily modified. And on the client side, run as client also needs to be modified because instead of just echoing from the socket as input to standard out, there's also the other way around, reading from standard in and sending that out to the socket. So there are 2 echoing going around, and you cannot just say echo loop and echo loop because each loop is a complete loop. You cannot just say finish one loop and then start the next loop. And the other thing is you also cannot use just 2 things here because you have to use a select call to see which one has something to read first. So are we doing okay with this? With socket 1. Now with socket 1 out of the way, what I'll do today, for the probably the remaining part of the class, or if we finish early, we can move on to something else, is I'll just kind of talk about the pseudocode of socket 2. In other words, this is not actual C code, but it is just pseudocode. I'm not going to start from the beginning, so I will assume that people know how to make 3 connections, or get 3 clients to connect to you first. Okay, that's really just code that you can copy and paste from socket 1. So once we get through that, okay, I'll just say the assume 3 clients are connected already. Okay, so we can make that assumption. So what you do is you have a really big loop here. The outermost loop, it will say while, which you can read as long as there is at least 1 connected client, do the following. Okay. This is the way I usually write my programs. I don't, just write it and then, wait until the end to type the end while. I always type, while, end while, or if you prefer curly braces, I always open and close at the same time. So this way I don't miss the stuff in between. All right. So what do we do as long as there's at least 1 connected client? The first thing you have to do is to see who can still read. Okay, who is still possible to write to you. Okay. So you need to say determine.
But Are you assuming that you have a buffer, like a single character buffer that you're
Single character buffer.
So don't you need to make sure that you don't have anything to write first?
But it is the logic automatically ensures that by the time you get to the outer loop, you would have that one single character buffer available again.
Okay, I'll see how you write it now.
Okay. Okay. So the first thing you have to do is to prepare for select call on reading from the clients. Okay, because you don't have anything to echo unless you have a character already read from at least one of the clients. So you want to determine the read set for your select statement. Okay, and I'm saying this here just to say that you have to do some logic to make that determination. It's not really static. It's not just, oh, okay, I need to listen to this, this, and this, because that list can change depending on which client is still connected. Okay? So then you make a select call. Now when the select call returns, then you will start another loop. So you can say while there is if at least one connected client has
Something to read.
while the server can still read at least one byte from one client. Okay, I think that's better. All right, sometimes phrasing it is the problem. Okay, so I'm not going to tell you exactly how to do that. I can only say that it has to do with the read set from the select call, and you have to use the macro. I think it's fd_is_set, all in uppercase. So those would be useful for this call. To limit this particular loop. So while the server can still read at least one byte from one client, we'll do the following. Okay, so we'll go ahead and read 1 byte from one client. Okay. In fact, we'll go ahead and say run 1 byte. And we'll call it ch. Okay, we'll use a variable ch to store that 1 byte. That is your buffer. Your buffer is only 1 byte long, and that's it. Okay. Well, once you read that 1 byte, you have to echo that to all the clients. So every client that is connected to you, including the client that sent you that byte to begin with, you have to echo it back to everybody. It is actually harder not to echo back to the client who sent you that. It's actually, you need extra logic to say that, oh, okay, you are the exception, I'm not sending it back to you. It's easier to just blanket and say, okay, everybody gets this character back. Okay, so what you need to do then is to determine the right set this time for the select statement. Okay, you don't read anymore. You have read 1 byte. You only have 1 byte as a buffer. It is already used up. You cannot read anymore. So now it's time to write back to the clients. So you have to determine, who can potentially be written to, which means, all the clients that are still connected. And then you need to do the following. Then you can say while the server can still write at least 1 byte to one client, do. And while, what do you do?
Select.
Yeah. Well, actually, I forgot to select here, didn't I?
Yeah,
Yep.
yeah, you need it before the while.
Well, don't you
You're gonna need to track who you've written to, because you have to write to everybody, whereas with the read, you don't have to read from everyone.
Yeah, I need to turn this from a do while loop from a while loop into a do while. While the server has not written to all clients. The reason why I turn this from a pre-checking loop to a post-checking loop is because I can put the select here now. So put the select call here, and then after that, then you put it into the loop and say, while the server can still write one byte to one client to at least one client do, while write to client C. And I'll even give you a clue what to write to client C.
But Dr. Tack, don't you have to modify your write set every time before you select?
Yes, you do.
You're not
Yep.
doing that.
Oh, okay, you do. Copy that to here. There you go. Very good. All right, and there are many, many ways to keep track of that. You can keep track of this part, like who has been written to.
Right.
You can either use a spare FD set to maintain, the file descriptors that have not been handled, or you can go through the array of client structures and see, and check the state and see who has already been written to. So as you write, CH to client, change the state of the client. Okay, and that means, before you do that, you have to reset the state of all clients. So reset the state of all clients. Okay. Are we doing okay so far with this? It's not very, exact, but that's just giving you the general idea. Yep.
So every time we read a character, we're going into, we're then writing using a select statement until we get that byte written to.
And until everybody gets it. Yep. All right. So that means, okay, there's one special condition that I have not handled here. What if, in the attempt to read one byte CH from the client,
It's in the file.
it hits you're hitting. It tells you that I actually did not read anything. Okay, what do? So now you do the conditional statement. Okay, if there was nothing read, then you want to do something. The else part will do what we just described here. So now I need to fix the indentation. All right, this is line 9, that's line 17. 9 to 17 shift. Go. All right, so if there was nothing read, then what do? What does it mean?
You need to close that server and change the state of the client
Yep.
to reflect that.
Mark client C
Did I say
as
server? Close that file descriptor.
disconnected. Huh?
I think I said it wrong.
No, you said it right.
Oh.
There we go. Okay. Are we doing okay so far? Okay, so you have to somehow determine, which client to read a byte from, and once you try to read from that client, and you're reading back 0 bytes, that means that connection is just broken. If it is broken, then you don't have anything to echo. You just have to mark the client as disconnected. Okay. When we reset the state of all clients, you have to make sure that you don't accidentally reset the state of a client that is already disconnected. So disconnected stays disconnected, but the ones that are still connected, you have to say it is not only the connected, but I have a byte to transmit to that client as well. Okay, so I'm not quite clear as to what you reset the state to. So you have to you have to find out how many states there are, and then find out how to represent the states. And I think that's it. That should be the logic on the server side. Any questions about the logic on the server side?
I haven't gotten there yet in my implementation, but if one of your clients is trying to give you 2 bytes, you read 1 byte from them, and then you want to write that byte back to them, are they going to fail on the select of the write set? Because
On the client side?
No.
Yeah.
No,
Oh,
because
okay.
they're independent.
Right.
So
and
that's,
the
yeah, I
sets are
can
independent.
give you the pseudocode for that too. So this is server side, and then we can handle the client side. The client side is actually quite a bit simpler compared to this because it only has one connection to deal with. But on the client side, you also have a while loop. The while loop is basically saying while the socket and standard in are still open, do the following. Okay. You can also use a do while because you don't really know whether the connections are open until you try to read from those particular file descriptors. So I think for the most part, using a do while loop may be a better way to do it because you have to do a select call first, read, attempt to read, and then you can decide whether they're still active or not. So a do while loop probably is a better way to do it. So in a do while loop, what you do is you have to there are two directions you have to handle, okay? But the two directions that you have to handle, you have to use a single select to deal with both directions. So the logic of this part can be a little bit tricky because you have to know the state of each side. Am I trying to echo back a character that I read from standard in, or am I trying to echo back a character that I have read back from the server? So you need two characters for two different buffers because each direction has its own buffer. Okay, are we doing okay so far? Okay, so that means if socket to standard out is idling, is idle, then set the read, set read and write set accordingly. And if stdin to socket is idle, then do the same thing. So there are actually 4 conditions to deal with. If socket to standard out is idling, you do it one way, else you do it another way. What is the else actually corresponding to? If socket to standard out is not idling, what does it mean?
Is this after we assume that we have read something, or?
Yep. You just read something from socket, so it's time. So it's time to try to output it to standard out. So then in that particular case, you have to set a different flag in a different set. Okay.
Is this after we've done a select statement for the read? Or?
Nope. This is not. This is before you do the select statement. This is actually helping you determine the read file descriptors and the write file descriptors for your select call.
I'm not clear what you mean by idle in this circumstance.
Idle means there's nothing. You're waiting.
Okay.
Okay, I can rephrase this. While if waiting from socket, yeah. And then this one is while if waiting from static in. Okay, are we doing okay here? It's because you have 2 directions. Okay, let me just draw a picture here. Okay, you have your socket, and I'll just say it's the same file descriptor, but you can use it for both input and output. So logically, there are 2 things that you have to handle. So you have socket in, you have socket out, and then you have standard out, and then you have standard in, right? Your program is a pump, but it pumps in both directions. When you see something from socket in, you echo it to standard out. When you see something from standard in, you echo it to socket out. Is that okay? So that means you really have a few things to wait for, because initially, when you first start the program, you are waiting on socket in and standard in at the same time, because there's nothing to output. You're just waiting for the input at the time. Is that making any sense? So initially, your wait or your select is selecting on, reading from standard socket in and also standard in. Now, which one is going to unblock first? We don't know. Okay, it is possible another client is sending something to the server, so you end up unblocking your socket in first. Then you have to block on standard out because you are waiting to see, okay, is standard out available? Can I send a byte to standard out? But you don't want the echoing from socket in to standard out to unnecessarily block your reading from standard in. Is that okay so far? And the flip logic applies too. If you read something from standard in, then you have to echo it to socket out. But you don't want to just say write to socket out without selecting first, because if socket out, if that particular connection is already filled up, and the server cannot take anything anymore, you don't want this block to block you from reading from the server in and echoing on standard out. Because each direction can clock independent to the opposite direction. Are we doing it? It's like a two bidirectional highway. This part of the highway can have an accident, and it's jammed up. Okay, so traffic is jammed up here. Okay, but it has nothing to do with this direction. It is completely independent. In other words, other clients can still be spewing out to the server, and you end up with a lot of gibberish displaying on standard out. Yep.
What about the people looking at the exit?
We put a baffle between the two lanes. Yep.
So do we ignore standard in if it's traffic jam?
If it is jammed up, to standard out, yes, you have to wait for standard out to clear.
Okay, so we save it and then try to.
Right. But it doesn't affect the opposite traffic. So when this is all jammed up, the other direction can still be moving really, really fast. So you can still be receiving stuff from standard in, and you have to echo it onto standard out. So you cannot just let this clock up the other side, because they're independent. They should not be clocking up each other.
Yeah. So we could just say standard in and then try again later.
You don't try again later. You just use a select call and say that unblock as soon as one thing is ready, unblock. Remember, select is an or operation. You're telling the operating system, wake me up if this guy is ready, or this guy is ready, or this guy is ready, or this guy is ready. So when the operating system unblock select and your program gets control back, the only thing that is guaranteed is at least one of the things that you're waiting on is now ready. So then you have to use fd_is_set on the right FDS and the read FDS and the write FDS to see what is available, and then process that accordingly. Is that okay?
Yeah.
Okay.
Dr. Tackler, from the client side, you're just going to select on the write set or the read set, not both of them. You're not going to have one, you're only going to select on either writing or reading from the client side, correct?
In each direction, yes.
Okay.
Yeah, in each direction, you're only waiting on only one side or the other. So if I want to be very clear here, if you're waiting from the socket, then you only have to set the read set, but you don't have to set anything on the write set. And then the opposite one is true as well. Because if you're not waiting from the socket, that means you're busy trying to echo it to standard out. So you have to change the write set in that case. Okay. So I'm just going to make this more clear by eliminating the one that you do not have to deal with. Okay, but I'm not telling you which bit to set in each particular set, because from the context that should be clear. Okay, so after you have the read and write sets properly configured, then you make a select call. When select returns, then you have to go through this logic again. Okay, so there are 10 lines here. So we go ahead and copy the 10 lines. Okay. So if you're reading from the socket, you should at least first check, okay, check and read if ready. If you are not waiting from the socket and you're actually trying to echo to standard out, then you should do the same thing here. You should check and write if ready, and it's the same thing here. Check and read if ready. check write if ready. Except now you have two more things to check, because how does the okay, you have to check two things, because remember how this loop is supposed to get out, how to get out of this loop is when the socket and standard in are both open. In other words, there's still stuff to read. So when you actually read, you have to handle the case when nothing was read. Because if nothing was read, if you check the read set after select, it says something is ready or an event has happened. You try to read, in this case from the socket, and it says, "Well, I didn't read back anything." That means that connection is closed. The server has actively disconnected the connection. So now the client has to say, okay, since the server is not talking to me anymore, I'm going to save that state and later on use it to get out of the loop. Okay, a bad programmer will probably use a break statement at that point, or go to, even worse.
So when you get that end of file signal on standard in, you're going to have to echo it to the socket. So the socket, the server knows that you've closed. But when you get the end of file from the socket, you don't have to echo that to standard out, right?
No. When you get end of file, you don't echo anything. You just quit.
We just close it, yeah.
Yeah.
Wouldn't that cause all the other clients to disconnect?
Sorry?
If you wrote the client correctly, but told the server to echo
One
the file-
condition, yeah, this condition should never happen, right? This one should never happen. Because the server is supposed to be the last one to quit because of the loop, the way the loop is set up.
But if the server sent end of file to all the clients when one client sent end of file to the server, wouldn't all the clients then potentially disconnect?
Seems right.
Say again?
If the server sent end of file, well, I guess they'd still be able to read it. So never mind.
Yeah.
Yeah.
Okay.
Yeah, killing one won't kill all.
Well, yeah, I was thinking if you actually send end of file, but you
So
could send 0, but it would still come back as one character read, which is not.
Yep. So
a condition.
I'll just say this here, optionally handle the case when nothing was read, but only for this case. For the other case, when you're still waiting from standard in, select sets an event has happened. When you try to read, it reads back 0 bytes. You have to handle that case because that means someone has just typed Control-D on the keyboard to terminate a client. So when the client is terminated, you need to get out of the loop and basically just exit the program. Because when you exit the program, the operating system will automatically close all these open file descriptors, which automatically close the connection from the client to the server. Then the server will respond to that and say, okay, I have to keep track of the states. So it would just say that, okay, this particular client has closed and I should not be reading from it or writing to it anymore. Are we doing okay so far with this program? So do we all know how to translate the pseudocode into C code using select? There's a lot of select here, a lot of FD, is set, and stuff like that. But for the most part, the arrangement of the logic should be similar to something like this. Any questions about this one? Are you guys ready to put timeout into the whole logic? So after a certain amount of time, we just say that I'm giving up on this client. Cross it out of the list. That's what socket 3 is about. Socket 3 has timeout in the whole
How are
thing.
we going to make our clients lag enough to actually check it?
Control S. You can clock one way is easy to clock. You just type Control S to clock up a client. The other way is to run GDB. Run your client in GDB, put a breakpoint, at a certain place. As long as it is in the loop, you put a breakpoint. So when the client hits that breakpoint, it's not going to do anything. Then the server can still, be feeding it stuff. But at some point, because the client is not selecting nor reading anymore, the traffic will get backed up. and at some point it will be backed up enough to the server side, and then the server will basically say, oh, okay, I cannot write another byte to this client anymore. So using GDB to run the clients will be very helpful because that gives you control over, whether it is processing or not. Yep.
This is not really related, but when I was testing my socket 1, I'd sometimes hit Control D on a client and it wouldn't kill it, so I was using Control Z.
Control D means end a file, but only on an empty line.
Okay.
So if you type something and then a Control D and then press the Enter key, it does not register as end a file.
Okay.
You have to type Control D on an empty line, and then I think Control D by itself should terminate. You don't need to enter after that.
Okay.
But it has to be on an empty line.
Thank you.
Okay, so are we doing okay with the logic? If anyone wants to test, whether you're handling the clogging part correctly, this is what you can do. You can write a very simple program. Okay, just I'm just gonna do it like this one. So I will just say echo. Echo is a real command, so let's not do that. Pump. Okay, there we go. So pound include unistd.h. All this one does is to do the same thing that we were talking about. So we'll use int char. Okay, we'll do this one as count, and this is my actual buffer. Do while and then we'll say while count does not equal 0. Count is read in from ch, reading into the character buffer, and I'm only going to read 1 byte at a time, and then I will write to standard out, same character, 1 byte. So this is a very, very simple program just to do simple echoing. It's reading from standard in and it's writing it to standard out. Okay, save the program, just do all the usual stuff. Run this pump program, doesn't do anything really any more spectacular than your first program, because your first program, standard in out, is basically just doing echoing. That's basically what it is. All right. So what we want to do is to test. Okay, but how much stuff does it take to fill up this pipe so that I can no longer echo stuff to this thing, right? That's what we want to do. So how do you think we should do that?
Redirect standard out.
Redirect standard out.
Is it going to be cat pump?
Yep, go ahead.
If you're permitting modifying the program, I have a solution. Is that a yes?
Well,
That's where your FIFOs come into.
the way I'm going to do it is to use a named FIFO or named pipe in this case, so that I can use the same for both instances of the program. In other words, I'll run pump in one case, and then I'll run pump in the other case too. But one should really be keeping count on the number of bytes written. Just trying to figure out what is the best way to do it.
What if you didn't ever read from whatever buffer you're looking at, but you read? I mean, you wrote to it, but you didn't read, and you kind of measured how many you wrote before write failed.
Okay, I think I know how to do that. Okay, let's do an unsigned and this is just a total count. Okay, so for each time we go through the iteration, we increment the total by 1. Just like that.
So we're trying to clog we're trying to read so much. What are we trying to do exactly?
Right. Okay, there we go. All right, so this is how I'm going to do it. We'll say pump from the FIFO that I just made. Oops. So this one is just blocking because it's waiting for something to come out from FIFO. So now I'm going to run it again, but this next time I run it, I will go run it from GDB. Yep. Okay, I run from GDB, and then this time when I run it, I will say run, but this will redirect from /dev/0. Okay, but on the other side, I'm going to do a Control S right now. Control S means I'm stopping the output. I'm just stopping the output. I'm intentionally clocking the output at this point. I guess I should have run this with GDB too. So I can run it with GDB, but run from, put a breakpoint first. I forgot to compile with the debug option. Never mind. gcc-o c pump. Go GDB pump. We'll put a breakpoint right on line 10, so it will stop on the first read. Run up. Okay, I forgot again. Redirect from FIFO. And the breakpoint is still active, so it will break when we have the pipe open. So in this case, we have the other program, and I need to get out of the, well, I guess I can just rewrite it like that too. Because I have to put a breakpoint in this case. We don't need a breakpoint, we just need to run it, and then we can stop the program. So this is going to read from 0, which is an infinite source of 0 bytes. Control C is supposed to pause the program, but not to stop the program. Like this one, you just pause the program. Breakpoint still active. Yep, the breakpoint is still there, but it's not stopping. I'm trying to determine how many characters the internal buffer of the kernel has, so that you guys can test it, by doing something similar. That part is not working.
Why don't you check the size of the FIFO?
The size of FIFO?
No,
You mean
ls-l.
I don't think that's going to tell me. FIFO is because FIFO is not an actual file. So it does not reflect how many bytes are actually in FIFO itself.
What about opening a socket, trying to write to it, and just seeing how many bytes you get until it fails? Well, if you open a non-blocking, I don't know. Or, I mean, you could even open it, you could open it for, I don't know.
Because we want to stop one, and then...
Is it just blocking because nothing's accepting on the other end?
What if you only ran one instance and you redirected the standard output to that FIFO? Would that work?
Let me try to run it without anything tricky first, and then see if it works. Okay, so this one will pump from FIFO, and then this one will pump from, let's say, a file, right? Pump.c itself. Nope. // and the other one is not getting it. Oh, I forgot.
To the file.
Yeah. That's why it's not. It wasn't working. That should work now. Okay. So that works. Okay, let me double check everything. Yep. So that works. Okay. I forgot to redirect the output of the other instance. Okay. Let me redo this again. Okay, GDB pump list, and this is just the receiving end, so I'm going to block on line 10, and we'll just go ahead and run it, redirecting from FIFO. So this one is going to block, when we get to that point. And then with this one, we run GDB. But when we run it, we redirect from the 0 file from device. We redirect, I forgot about the redirect output to FIFO last time. So this will actually block at some point, it should be blocked by now. And then we do a Control-C, it stops the program from executing. And then we can look at a stack trace. I cannot remember how to do that stack tracing. So we'll go help stack, backtrace. And backtrace says we are still on line 11 of pump. And the question is, can I get back and display the local variable at pump at main? So
Local variables are on the stack, aren't they?
they are on the stack.
Because you can actually take a look at the stack frame with those commands.
With backtrace.
Well, the other commands
ET.
there, for instance, frame.
Select a call frame without printing anything. Frame 1. Oh, nice. So now I have just changed my context to frame 1, and then we say print total. It's 64K. In other words, with this program, if you want to test the blocking feature, you have to stop one side, and the other side will have to send about 64K of stuff before the pipe is completely full. In other words, your highway has a length of 64,000 cars, or 64K cars. So in order for this end in order for the client to be clogged up, you need to have 65,536 cars on the highway until the traffic jam clogs all the way back up to the source. All right.
We're trying to make the timeout. We're trying to.
No, this program has no timeout. This program, you just want to make sure that you're not blocking unnecessarily. Because I can make a test case where I make one particular client, slow down or stop completely. You should still be able to echo to all the other clients. The other clients should work normally, but since this client is not reading anything from the server, so eventually the server will have to stop because it can no longer echo to this particular client.
But Select's going to take care of that for you, right?
Right, but it will just block. The server will have to block at some point, right?
So,
Yep.
if I understand correctly, we're not going to go back and read anything from any other clients until we've written to all our clients. So if we've written to all
Correct.
so we're going to write to all the clients, but if one client is still blocking, then we're just going to sit there on that client.
Yep.
Okay.
Yep. If you have one left and it is just not cooperating, then you have no choice because you
Okay.
only have a buffer of 1 byte.
Right. Okay, thank you.
So I'm just going to go back to the logic here. In other words, what you are talking about is the inside loop here. What you're referring to is this inside loop. You
Yeah.
cannot get out of this loop until
You're
the
stuck.
server has written to all clients. If one client is not cooperative,
You're stuck.
it can, it can basically clog up the entire operation. Because if you don't get out of this loop, you cannot get out of the conditional statement. Then you cannot get out to this end while. And if you cannot get out to this end while, it cannot read another character from another client. So that basically blocks the entire thing. Yes.
So we
Alright.
should never have a problem, we should never get that far where we have it all clogged up, should we? Oh, that, with the STD in, okay, got it.
Yeah, you can't get clogged up like this, because I can run your clients using GDB, so I can intentionally put a breakpoint at a particular place, so that one client is just saying, I'm not doing anything, and then the server will still have to echo to the other two clients, but eventually will have to stop because this client is not responding.
Yeah,
But
so
we'll be able to dump 64K characters.
Correct.
Before that happens.
Yeah,
Yeah,
the
per
combined input from the other two clients from the server side has to be up to 64 kilobytes before everything gets entirely clogged up, because the pipe to this particular client has a length of 65,000 cars. So you need to send 65,000 cars before the server will basically say, oh, I cannot send another car through this exit anymore. Yep.
But you could probably do that just by having dev0 as your input and an actual file as your output. Because dev0, I imagine, would be much faster than
Mhm.
hard drive I/O.
Oh yeah.
As we saw.
Yes.
So, we're gonna, let's see, if something's, I lost my question, sorry. Come back to me.
Now, your number may not be exactly the same, because in this case, when I tested it this time, I was using a named pipe. Inside the kernel, a named pipe may have a different buffer size compared to a named socket. Last time I taught this class, I believe the named socket size is actually smaller. The buffer for a named socket is considerably smaller than 64 kilobytes. But I was using a different kernel also, so I cannot tell whether it's the kernel version or whether it has to do with it is a socket versus a FIFO.
So,
Yeah, he has a question first. Then
would
I'll-
a scenario be, let's say you have one client that's not responding. So you'd have all these other clients that are sending characters basically, and the server's gonna be reading those, and it's gonna keep on sending them to that one client until
Right.
that's all clogged up, and then the
Mhm.
server's gonna block.
Yep.
And then all those clients are gonna start filling up the socket going to the server.
Well, kind of imagine that each client, let's say these three are my clients, each client has an in tray. Okay, let's look at this from an office perspective. So each person or each client has an in tray and an out tray. I'm the server. Okay, so I will just periodically, I will just check who has something on the out tray. Okay, so let's say you have something on your out tray. Okay, I'll take the out tray. Not your phone. Leave your phone. So I'll take something from your out tray. I run to the copier and make 3 copies. Okay, and then I'll put one copy onto your in tray, one copy on your in tray, and one copy on your in tray. Okay. And then next, let's say you have something on your out tray. I'll do the same thing. I grab whatever is on your out tray, make a photocopy, put one copy back onto your in tray, one onto your in tray, one onto your in tray. Okay, so I'll keep doing this until your in tray is stacked up to, in this case, 64 kilobytes. At that point, okay, let's say your in tray is already stacked all the way up to 64 kilobytes. Then it will go like, oh, if I put another piece of paper into this in tray, it's going to break the tray. So I'm just going to sit back and go like, okay, we'll wait until that in tray has some room.
But her,
So if, yeah.
I'm sorry, go ahead.
Yeah, so as long as that in tray still has 64 kilobytes, stacked up, I'm just gonna sit here because that's the only thing I can do. I cannot, even if you guys have both, stuff on your out tray, I cannot take it because I only have a buffer of 1 byte. I still have this one document that I have not redistributed to one of the clients. So I cannot take your out tray material as a result.
So which select call is that's going to block you? Because I thought if you had one thing in your in tray, then you won't write until we take that out of our in tray and then say I'm ready. But some select call is still going to return.
It will be this
even though
select
you
call.
have.
This select is the one that's going to block.
Okay.
Because we have to determine the right set for the select.
Okay.
Okay. So, and then for each loop, we are going to determine, okay, who else has not received a copy of this byte?
Okay.
And therefore we'll determine the right set for this particular select call. So this select call, if you only have one client remaining, then this select call will boil down to only having one file descriptor in the set.
Right.
And that will be the one that's blocking us, because as long as that client still has 64K in the in tray, this select call will not return. It will still be blocked.
So that means what, they're being written to, but they're not reading it?
Correct.
Okay.
The client is just not reading it fast, at least not fast
Not
enough.
fast enough, okay.
Right. Yep.
So looking ahead to select 3, then if she has 64K in her inbox that she hasn't dealt with, the timeout eventually is going to say, we're tired of waiting on her. Is that
Yep.
the way that's going to work? Okay.
Yep. So the timeout, there are really only a few ways to handle a timeout. One is basically just say that, okay, she will just get one fewer byte. Okay, so for this particular byte, after we time out, after a certain period of time, she's just going to miss it completely. Okay, that particular client will just miss it. The other way is basically just to disconnect.
Cut
But
them
yeah.
Yeah. No soup for you.
off.
Yep.
I like the thought of just cut them off. You don't have to deal with them anymore.
Well, when you're dealing with an actual protocol, you cannot just say, okay, we'll just, you'll just be missing a few bytes, because if you miss a few bytes, then it's not going to work.
Yeah,
Yep.
right.
And there would be no indication, as I understand it, that there was even a gap, because from the client's perspective, from the release load client's perspective, as soon as they read and open up space and the server says, oh, finally, here's the next thing, but we skipped some stuff. It doesn't say, hey, we skipped some stuff. It just gives some bytes.
Right.
That's terrible.
Yep.
Is there a way to flush the pipe? And maybe
To flush the pipe.
Yeah, you give up, and then maybe you try to.
You mean to empty out the pipe?
Yeah, and then
Like just to toss the entire in tray into the trash can?
Yes.
I think there may be a way to do it, but I do not know yet how to do it. It's probably one of the IOCTL or cisctl type of call that can do it. Yep.
Just out of curiosity, so are the input from the socket's input, basically the server's input, is basically just one pipe, so it's kind of like everybody's putting it into one box, right? Or is it? Do they each have
It's
individual?
funneling everything into one single character buffer,
Or
and then from
not,
that.
not a character buffer, but kind of like everybody has their in trays. The server really has only one in tray, and they all share that in tray, or do they each have? Does it
You
each have?
can, well, it's not like that. The server really has 3 in trays, because each out tray of a client maps to an in tray from the server's perspective. So as a server, I really have 3 in trays instead of just 1. But I only pay attention to 1 in tray at a time. When I make photocopies at the photocopier, I only take the content from 1 in tray at a time. So I'm not going to take a look at another in tray until the content from 1 in tray is completely echoed to all the clients. So the limitation is kind of artificial, because it's just based on the requirement of this protocol. I have to finish echoing to everybody before I grab another byte from any client.
So are we completely emptying one in tray before we move on to emptying one in tray, and then making those photocopies and putting it out into the others, the other people's trays, instead of reading one and then moving on and getting one from the other person and then getting one from the other person, documents at a time. Is that how you want it
He
to
said
be?
you can do it either way.
We can do it either way.
You can do it either way. This particular logic is more fair, because what I'm doing is, I will just, when in the other select statement, in the select statement here, okay, if there are if all three clients are active, that select statement will say, if any one of you have anything on your out tray, wake me up. That's what it's saying. Okay, now let's just say that all three clients have something to, on their out tray all at the same time. So I only get awakened once, but when I proceed after that select statement, my read set is going to have all three file descriptors set in that case. According to this particular logic, I'm not going to go, I will not even do another select on read until I look at my list and say that, oh, I remember you got something to, to write to me. You have something on the out tray. So I process your out tray and I echo to everybody. And then without using another select call, I will look through my list again and say that, okay, I just got your out tray stuff. Now I move on to the next client's out tray. Grab the out tray from the next client, do the echoing, and then I look through my list, I cross out those two items. Then I look at the third item, I look at the last entry on my list and say, oh, you also have something on your out tray. So then I get your stuff from your out tray, I echo to all three clients. Then I look at my list, it's all handled. I got nothing else to process. And only at that point, I would go back to do another select on read.
Which works great conceptually, but when you're actually trying to send whole words across all three.
Yes.
I was gonna say, what if they have like a whole packet they're trying to send, and you're just taking one sheet.
Then it will be interleaved. But when you test the program, it will be hard. It will be difficult for you guys to see the interleaving, because if you're testing this program interactively, then one particular client would have a whole pile of stuff when the other two still have an empty out tray. But one client, when you type something and then press the enter key, this particular client will have the out tray will go from empty to like that.
Yeah.
So from my perspective as a server, those two out trays will still be completely empty when every time I go through the select, I'll just be grabbing pages from one particular client.
But you
So
can
is
have
that
a lot of
gonna-
fun if you redirect a file to standard in. You can have a lot of fun if you redirect a couple files to standard in.
Yes, but you still have to time it because the speed of the operating system.
I did it to the first two clients, and then I didn't worry about the third client. As soon as the third client connected, then they started interleaving.
That's because you got two piles already filled up, and when the server goes to work, you already have you already have two piles on the out trays of two particular clients.
Right,
so
but it
why
let me
you see
test
the
my logic
interleaving.
on my server to see if I was actually doing the interleaving.
Right. Yeah, that's one way to check it is just to have start up the two clients, redirect first, and then start the server first. Start two clients, with redirection from a file. Start the third client. So when you look at the output from the third client or any client, you should see interleaving, complete interleaving. It's not just interleaving sometimes and not other times. You should see complete interleaving until whatever you redirected has exhausted.
Do you want us? Is it okay if we try to avoid the interleaving, or is that going to be a bad idea to do on this assignment? Because I kind of.
The assignment did not say that you have to be fair. In other words, you can.
Well, you don't have to, but is it okay if we did?
Yes. So that means you can prefer a particular client. You can say, as long as you have something on your out tray, I will only get it from your out tray. I will only look at the other two clients if you don't have anything on the out tray. You can do it that way too, because the assignment does not say that you have to be fair in this round robin fashion. Because the round robin fashion, there are a lot of other ways to make it fair too. You can just use a random. You can use a random number. Okay, if all three clients says I got something on my out tray, instead of going sequentially like 1, 2, 3, I can just say that I'll just randomly pick one. Okay, and then do the output, and then I go back to the select statement again and ask who has stuff. So the next time I pick, it can be any of the three clients because it's all random. So you can use random, and still be fair. And then the output, would be kind of unpredictable. Even if you start your program the way you did, it will still be unpredictable because when it's random, you can pick 2 pages from here, 1 page from here, 1 more page from here, 2 more pages from here. So, so instead of doing that, if there's just no requirement, state in the homework assignment, so you can do it either way. You can even have an unfair scheme where you prefer one particular client, which Sometimes it's easier, but if you use this logic, it's actually easy to be fair as well. All right. So I'll see you guys on Wednesday. And just try to work on this program. And if it cannot be done, then we'll see what happens.
Dr. Tack, I meant to ask